feels like at least net neutral.
I actually slept like 6 hours straight on Saturday. It was pretty impressive.
That's impressive.
It's been a very long time since I've done that.
Well, I hope even more sleep is on its way then. Hey, good news related to that. There's no labs this week, so we're studying and test purposes. That said, feel free to nap if you are tired. Additionally, so today I want us to look at the chapter 12 homework and quiz, which will be due tonight. The first test is now available for you to begin. That said, I don't advise you to yet because there's still a result assignment tonight. I'm putting it up now, but it is due midnight on Friday. So as long as it's done by then, everything's good. So you have all week to find a nice 5-hour gap to take that. It will only take you 1 hour, but the 5-hour gap is because sometimes you have to go to the bathroom or eat something, and questions getting answered by email is a delay.
You don't have any problem with it?
9. So,
So when you say Friday at midnight, I know it's going to be my question, but do you mean Friday at 9 p.m.?
correct. I do not mean the beginning of Friday, end of Thursday. So yes, Friday the 26th at 11:59 p.m. Excuse me. So, again, a couple things about the test. Since it's out of class, no lab this week. To help prepare for said test, I created a test tab on the Brightspace page. Within this tab, I will also translate this list of things so that you don't have to write it down or remember it. This is just the list of all the things that we have covered in chapters 10 through 12. And we'll talk about everything here briefly together, but I will also rewrite it here so it is available. Also within this tab, the reason it's here, is because I like to give students the option of looking at some practice questions. These questions are not the test itself. These are based on, it's like a compilation of questions that I've asked in the past that I've modified and I like to get out as review. So some students have just asked me repeatedly, do you have any new questions I can work rather than just looking at the old ones? And that's what these are. It's just more practice. And it's very, very similar to the questions that will be on the test. So if you're looking for something new to do in your studying, this would be
If we
it.
do those, can we send them to you?
Yes, additionally, you absolutely can. We can even talk about them on Thursday, but I've also uploaded the answer key.
Oh, okay,
That said, the math problems, what? Oh no, I have too many files, and some of them have names that become confusing. So this is the version of the key with the typed answers before I then scanned the other part. So I'm going to fix that, put the real key up there eventually, but the key will be available. What I did was, because my handwriting is complete chicken scratch, I typed out the short answer questions and was going to write in the math questions. That file exists, and it will be here soon. For the math questions, if my chicken scratch doesn't make any sense, please let me know. I will gladly translate, and I will fix this later today. But these are here as a resource. Class this week, today and Thursday, will consist of prepping for the test, and on Thursday, if you've been working these and have questions, you can come in and talk about them and work them together. But since this week's lectures are entirely focused on just test prep, no one is under any obligation to be here if you feel comfortable or if you get the test done early and then you just take the rest of the week off. So today, will be chapter 12 and setting up for the test. Thursday will be any questions you have while studying for the test if you haven't taken it yet. You don't have to come, but it is an option. That said, bringing up calendar again just for a sec. Next week is the first week of March, and things will resume as normal that week. We'll be getting, learning new material, and we will have lab again. So next week is normal, this week is weird test week. Also available to you as resources, where's my mouse? So within the test tab, we have these. I'm also planning on compiling every single formula table, sorry, not formula table, constant table, and putting them in here for you guys so that you don't have to go searching for them and things like that. So constant sheet will be uploaded here, and at the very top in the course info is the formula sheet for the entire class. So that is also at your disposal. All assignments, you have access to a formula sheet and constant sheets and things of that nature. And please ask me questions. This formula sheet is for the entire semester, meaning that we've only used part of it up till this point, really just the first column here. So there's a lot of things on it you haven't seen yet, that's okay, just focus on the first column. You also have your own notes, I allow you to use those, because you'll be taking it on your own space in your own time. You can use your notes and the slideshows as well. Hello?
No way. Really?
Well, if you ask me a question, I'm just going to parrot back what was in the notes. So cut out that middleman.
I mean, okay. I'm just shocked by that. Oh my gosh. All of my other professors, like last semester, were hard asses and were like, you can't even like look to your left while you're taking an exam on your own time.
I mean, I have no authority. I have no way to police that. Nor do I
can still
want
see it.
to. Besides, this is physics. The challenge comes from it being a weird question that you have not worked exactly before. So there will be challenge. I'm just not going to make the challenge having to remember what formulas exist. I tried. I like the challenge to be applying the knowledge to a new and different kind of a situation.
I appreciate your respect.
Thank you. I find, well, working physics, working as a physicist, the job isn't doing the same thing over and over again. It's figuring out how to do something new with it. Also, I presume most of you guys are going to be going into some kind of a scientific field. You're going to have your reference materials when you're working. I figure I'll give you this courtesy. I certainly wouldn't make a part of this industry if I wasn't allowed to look at my textbook. I don't remember. I can't memorize anything. Oh. Okay. Any questions about tests, concepts, formatting, etc.? Please send them, ask them at any time. I want to turn attention at least here at the rough beginning of class to the chapter 12 assignment, because again, focus on that more tonight if you haven't finished it yet. I've gotten some questions about it over the weekend, and there's some parts of it that I definitely need to talk about with everyone, because Cengage slipped in a few things that I would rather it had not.
It does seem to be that he tries to do that.
Yeah, it really does.
Is it like the friction stuff?
Hmm?
Is that what you're talking about?
No, friction, not friction. The issue is that, so all these questions came from the textbook. They were all loaded in by the textbook. And sometimes the things that it loads in doesn't always perfectly line up with the things that I would rather us focus on. So there are 3 specific pieces of certain questions that I feel aren't fair because they don't give you the information you need, or it requires some logical leaps that we'll just never need to make again. Like specific sub parts of things that I know will never come up again because I'm writing a test. And those questions are number 1, part C, because it's not very clearly asking what it wants, and I can't figure out how to get the answer the machine keeps saying. So, you know, that's a problem. So 1C, I have made worth 0 points. I can't remove it because the assignment has already been administered. I cannot edit that part out of the question, but I can make it worth nothing. So you don't have to do 1 part C. Next one that is being omitted is C part B, because this pulls up a whole bunch of chemistry stuff that I never talked about and that I don't have in a table to hand you. It's specifically, every single time you load up this question for a different student, it'll give you a different gas, some of which will be diatomic and some of which won't be. And it's up to the student to figure out what that molar mass is and then figure out what the specific heat of that specific gas is at a specific temperature, which is just too much information that is not given to you and that I have never mentioned within this particular class.
It's also like kind of hard to do.
Yes. I also can't get the number to perfectly match because I don't know what specific heat it wants. It doesn't say. And there's no table for every single diatomic molecule in the book we're using. So 6B is also worth 0 points. You don't have to do it. And the last part is 8D and E. Oh, sorry, E and F, excuse me. The reason for that is I don't actually know how to define repetition in this context, so I'm not sure where it's generating this answer from. This is edging too close into health sciences for my liking. And exercise sciences. I could not define a repetition until today. So I cannot exactly tell you why, based on just the definitions of the word, that this particular individual can't do reps at this rate. So E and F, the part where you explain E, are also omitted. But these are the parts that are worth 0 points. Everything else that is worth points is stuff that we have talked about in class, and that you either talked about in this class or in 1500, and that is useful to you and is on the table. I want to take at least a little bit of time to look at a couple of things that have come up. Let's see. In addition to those ones that I have omitted, I also want to look at 4 and 2 specifically with you guys. If you have any other individual questions, we will absolutely look at those, but those are the 2 that I've been asked about the most. So, number 2 is a callback, because it involves the old formula for work and the formula for friction from 1500. So, to refresh memories, all friction, regardless of what subtype it is, force of friction is equal to normal force times coefficient of friction. In this particular example, a skier of some mass is skiing horizontally across snow. We are given the coefficient of friction between the ski and snow, which you'd hope would be lower than that, frankly. I would want the skis to glide as effortlessly as possible. assume that the snow is at 0 Celsius and that the force of friction present is generating thermal energy. By its very nature, friction does work and takes kinetic energy away from whatever it's working on and just turns it directly into thermal energy. Again, how we warm hands and why most car engines will overheat if you leave them on too long or without a cooler. So, in this physical situation, the skier is skiing, there is friction between ski and snow. The friction will create thermal energy, and enough of that thermal energy can eventually melt the snow. So this is sort of a three-part combo of concepts. We've got friction, work, and phase change. And the way that I recommend working this is sort of in reverse. We want to figure out the distance the skier must slide to melt an amount of snow. Everyone will have a slightly different amount. And the farther you slide, the more thermal energy you will produce. This is because the farther you slide, the farther you move, the more work the force of friction will be able to do. So the chain of events that I recommend looking at are, first, we are told amount of snow that will melt, or that we want to melt. Mass of that snow times the latent heat of fusion for H2O will tell us how much heat needs to be produced in order to melt that much snow. That amount of thermal energy will be created by the work done by friction. So the next step is that amount of work will be equal to the force of friction times the distance that we slide. So we are solving ultimately for delta x. The Q we find up here can go right there. It's going to be equal to force of friction times delta x. We still need to find that force of friction. We were given mu, so callback time, how does one find normal force?
That's not correct, right? Or it is the same as, if we're on horizontal, it should be the same as this way.
Very good. For the sake of simplicity, and because the question tells us we can, we're just going to be skiing horizontally across horizontal ground, not accelerating up or down. That tells us that normal force and the force of gravity should be equal and opposite. We are told the mass of the skier, multiply that by 9.81. So I'm taking it the next line down and plugged in a few things. This amount of thermal energy, the amount found up here, be equal to the weight of the skier, mass times 9.8, times our coefficient, times delta x, which is ultimately what we want. Keep in mind, this mass is different to this mass. If you were to plug this in for Q and have ml equals mg mu x, they're different masses, they don't cancel out. Any questions about that one? Yes, okay. I want us to look a little bit at 4 as well, because it takes a little bit of algebra and formula playing with formulas, I think, to get to the easiest way to do this one. And there's a little bit of confusion in the way that the answers are worded. So this is chapter 12, homework number 4. We have gas stored within a cylinder, like with all of our pistons so far. And what's going to happen is, we know how much gas is present. We have moles of some amount of gas. And this gas is going to be heated up from some initial low temperature to some high final temperature. It's going to heat up, and it's going to, well, when you heat up gas, what happens to it? Okay, so we know volume is going to be increasing. This is helped by the fact that we are told in the problem that the gas pressure is going to be constant throughout this entire process. P won't be changing, and neither will N, because it's going to be the same amount of gas the entire time. Those two things being constant helps simplify things. What we are first asked for is the work done on the gas as the temperature rises. So we know moles of gas, temperature of gas is changing, we know pressure is going to be constant. What formula is that calling to mind?
I'm sorry, can you ask that question again?
Okay. We are told moles of gas, the volume of the gas is going to increase as the temperature increases, and the pressure is going to stay constant.
Ideal gas law?
Okay, good. That formula has all the things in it that I just said. PV equals nRT. But if we're, this formula by itself won't tell us work. Because the thing that we are ultimately looking for, work done on the gas, is not here. This is helpful, but we still have to do something to it. We want work done on the gas. We have a formula for work done by the gas. Work equals P times delta V. Why does my delta work like that? The problem here is we don't know delta V. We also don't know what P is either. At no point are we told what the pressure is. So, I recommend employing a little shortcut. Do you guys remember when we took this and split it back down into a bunch of smaller formulas that related each of the principles to each other if certain things were held constant? I'm going to take one of those and combine it into this. We're holding, throughout this warming process, pressure and moles constant. Temperature is going to rise, and volume is also going to rise. If these two things are constant, then we can legally rewrite the formula like this. We know from our other gas laws, if these two things are constant, the volume change is proportional to the temperature change. Kelvin. Which gives us a neat little shortcut. Work equals P delta V, and P delta V equals nR delta T.
Yes.
So for this particular question, work equals nR delta T, which saves us the step of converting to Kelvin. If delta T doesn't matter. One minor note, we haven't used R in a minute. This question is going to require the question requires the 8.317 version of R. There is a reason for that, but it's buried in the math, so I just wanted to make sure I told you first. For work to be joules, using this version of the formula without the times 101.325 added on. These need to be pascals and meters cubed. And this is the version of R that we use for pascals and meters cubed. If we were to use liters and atmospheres, we would have to use a slightly modified version of this formula and a different R. So, since we're not actually plugging in liters and atmospheres, I wanted to make sure that was known.
Why is it negative?
That's a very good question. That's the next thing I wanted to talk about. This will get you your numerical answer, no problem. Problem is, WebAssign's expecting a negative number. And that reasoning is in the wording of number A. So it asks to find the work done on the gas as the temperature increases. If the gas's volume is increasing, is it doing work or is work being done on it? It's doing work if it is expanding. So if we were solving for the work done by the gas, we would work this and get a positive number. Meanwhile, if it's doing that much work out of itself, that work is then being done on the system. So the system's not really doing work, it's being worked on, which means the work done by the system is a negative number. And I don't know why physics insisted on labeling all the signs like this.
So you don't need the mass or the contact area when you use that?
Yes. Since it's a vertical piston, there are ways to utilize the mass in the contact area. Because as the gas expands, it's going to lift something and do work by lifting an object. So you could work it that way. I like this way. The other way would work though, you just need the GPE formula. And then you use that to find change in volume by the change in height. Still with no pressure though, which is why I prefer this way.
And that's for constant pressure.
Correct.
So if you were to change pressure, but leave temperature alone, or if something's isothermal and it's expanding, the pressure is going to change.
Yes.
That can be assumed.
So this would be isobaric. Those are what I think are all of the things to be concerned with on Chapter 12 assignment. Any questions about anything at all? Okay. Again, my priority, I advise your priority to be making sure you are completely finished with this and the quiz, and that you understand this and quiz before working on the test. For the test itself, it is about chapters 10 through 12. And this is the list of things that we have covered in that span of time. All formulas are on the formula sheet and in your notes. So that said, I will briefly mention what all formulas up here are. So all the things we've covered, and I expect, no, I've made the test. I know there's about one question per concept here. So you're familiar with all of them. We began in chapter 10 with the different temperature scales, so make sure you can convert between them. Thermal expansion, and That's both linear and volumetric expansion. And gas law, PV equals nRT. In chapter 11, moved on to specific heat and used it to do a lot of calorimetry problems, and I misspelled calorimetry up here. Then phase change and thermal conductivity. The chapter 12 stuff that we've done math for, didn't talk about all the laws of thermodynamics, but the problems that will show up in terms of the math are first law of work in heat engines and second law efficiency. We talked about entropy, but we did no math for entropy, so there will be no entropy math. Bless you.
If your pressure is changing,
Again,
if your pressure is changing, how can you calculate work? Because work
great question.
assumes that pressure doesn't change.
There are calculus ways to find it using just formulas. I don't like those because I'm a geometrically trained person. So what I like to do is, let's say you were looking at a heat engine graph, pressure versus volume. This particular homework has a few of those in it. There's a multiple choice question where you are choosing which of these graphs best matches the situation described above. And these graphs are designed to show how the pressure and volume change based on each different part of the system, with an arrow to specify what direction you're going in, because that's important. Now, this is easiest when you go in steps of 4 and everything forms a nice box. When it's a box like this, the work done by the machine is the area inside the box, which is just the sum of all the individual works for each line. Taking into account one of them would be a negative number because it's going in reverse. But you only get a box if pressure is constant while the volume changes. You could get a heat engine that changes pressure and volume at the same time. Kind of combining these two legs into one right triangle. Now, because pressure is not constant, we don't use the same formula here, but we can use geometry. Because the work done by the machine is still the area under the curve, or the area of the shape. So, as a quick sample, let's say that 1, 2, 1, 4. The area of this triangle would be 1 times 3 times 1/2. And that would be the work done by the machine in every single part of this process, like totally combined. But to find the work of just this one step, instead of the area of the triangle, it's the area of everything under that line, which would be the triangle itself plus this little piece down here. So if you were trying to find the work done in that one specific step where pressure and volume are changing at the same time, I would either give you everything you would need to sketch this graph, or you would have the graph. Area of this triangle plus the area of the rectangle that's on top of it.
So I believe you.
Sorry?
I believe you, but
Okay.
like, I'm looking at our quiz right now, and it doesn't give us that. So we have to know how to do it without a graph.
Oh dear. What did happen?
It's like, it gives us the change in volume, thermal, and the moles. then ask us how much work it does. Which, like, I know there's a way to do that, but I am trying to not have to use, like, take the derivative of it and then use substitution.
Yeah, that one, I'm gonna be honest, I like looked it up and I had to do natural log for part B.
Thank you, Emerson, so much.
Really learned a way to do it in P10. But like that's like not necessary for this. So there has to be an easier way.
Okay. You should have volume for two parts. You have constant N, constant T. It should be possible to use gas law to find the pressure at each volume.
Yes.
And I would draw the line and then do that math. Do this.
Can you explain again why you include the rectangle underneath the triangle?
So if we were just solving for area under the curve, that is the literal area of this shape formed from between this line and the zero axis. And when I am finding area under the curve, I try to break it up into geometric shapes. You've got the right triangle here, and it's on top of a rectangle. Because I'm sure there is a formula for a weird trapezoid like this. I just don't have it offhand.
I'm doing what you just described about like drawing the line, so I'll let you know if it works.
Well, I instinctively, or on principle, like the idea of giving you guys something I can't do myself, so I'm going to make sure that works too. So I'm going to do this real quick, and if anyone needs water, restroom, or just a general brain break, this is a great time for that. And I'll get back to you momentarily. Okay, that does work.
I think my units were wrong, but like, yes.
Hmm?
I got it to work, I think, as well.
Okay, yes. Using ideal gas law, you can solve for the two pressures. Draw out the shade.
I like instinctively converted everything to atmosphere liters. So if I got my answer in atmosphere liters, I would have had to have had multiplied it by 101.325 to get joules.
Okay.
Okay, I didn't do that, so it's wrong. But
Okay.
I'm like making sure that's the correct way to do it.
Yes.